Hello, everyone. Good evening. How are you doing? Am I audible? Okay. Give me 1 minute. We'll start. Let others also join. Okay, they are still joining. Okay. Could you see the screen? Okay. So where were we last class? What have we done? What is the last part we have done? Have we finished average atomic mass? Okay. Right. Solve this one. Okay. Try this question. Carbon occurs in nature as a mixture of C12 and C13. As a mixture of these two, the average atomic mass of carbon is 12.011. Find the percentage abundance of C12 in nature. Try this question. Okay, done? Yeah, 98.9 is the correct answer. But I can see only few of you have done, only 5. I can see the answer now. I'll do it, Kiran, in just a second. See, the question is what? We have a carbon sample, right? We have carbon sample, and this carbon sample has two different forms. Means it is present in the form of C12 and C13. In the question it says that if you take a carbon sample, right, then it has two different components we have, allotropes of carbon. However, C14 also we have, but in this question it is not given, so we won't consider that, right? We need to find out what percentage of C12 is present in the in this sample, right? So since percentage we have to find out, so I'll assume this as X, so this should be 100 minus X. So it is X%, it is 100 minus X%. Okay. Now these two allotrope, contributes into the average atomic mass of this? Average atomic mass of this, correct? So the average atomic mass formula we have already seen, the percentage abundance into its atomic mass plus the percentage abundance into its atomic mass, that is 30. Now this is given in the question, which is 12.011. That would be equals to 12x plus 13 into 100 minus x. This whole thing is divided by 100. So now when you solve this, you'll get x equals to 98.9%. Right? This is the answer to this question. Did you get it, all of you? Correct. Try this. Did you see this? Solve this one. The composition of sample of strike is Fe 0.93 O100. How did you do this, Akshat? Okay, I'll do this. I can see only 4 5 answers here. So you see this question. The sample is Fe 0.93 400, right? What we'll do into this one? We know this ion present at with two different oxidation state, which is Fe plus 2 and Fe plus 3. This is the two different oxidation state we have for iron, plus 2 and plus 3. Right. Next, what we'll do into this one, Akshat? Yes. Okay. Amount of iron should be that and substitute. Correct. So what we need to do here, if this is if this is x, if this is x, this I am assuming 100 minus x. Oh wait, not 100. It is 0.93 minus x. So that the total is 0.93. Right? Now we can balance the charge here and we can solve it. Okay. Oxidation is state because the molecule overall is neutral. Just a second. We got some disturbance. Just a second, guys. Yes. So what we can do here, if you multiply with the charge, okay, so we are discussing this question composition, right? So 3x plus 2 into 0.93 minus x is equals to what we should write on the right hand side. Could you tell me what should be on the right hand side? Is it 0, 100, 0.93? We're balancing the charge, right? So what should be the charge on oxygen? minus 2. So minus 2 into 100, that would be 200. But I don't think here we should have 0.93. I think it is 93, or the formula should be this 0.930. I'll cross check this just a second. Okay, I think this is the formula, or we can write this formula as this 93,000. This way also we can write. But we'll check this in this what we get. So we get 2 into 0.93 minus x equals to 200. X equals to what we are getting? 200 minus 1.86, right? Which is not possible, you see. We are getting 198 point something, which is not possible because total it is 0.93. No, minus 200, we have this side equals to 0. Right side will have 0. So minus 200 will go on the other side, becomes plus 200. Okay, actually the equation is this, I'll show you. The equation is this. This equals to the molecule is neutral, so it is 0. And hence it becomes this. Right? So this is the one thing that is here. Now the change here is what? That this molecule, if it is this, now you see what we get from this one. If you're considering any one of this molecule, then again, suppose Fe 0.930 we have. So in this Fe3 plus, Fe2 plus, if it is X, it is 0.93 minus X. Okay, so this, if you balance the charge, 3x plus 2 into 0.93 minus x equals to 2. Now when you solve this, it will be 2 minus 1.86. That will be 0.14 approximately. Okay. Right, 0.14. So when you find out the percentage of this, so percentage will be 0.14 divided by 0.93 into 100, which is equals to 15.5%. Yes, yes, that is also fine. You have taken the account of iron molecule, no? But this is here, 0.93 is fine, but this oxygen should not be 100. That's what I'm telling you. Your method is right. Because since you did not consider this oxygen part, that's why you got the right answer, Akshat. Right? So this is Fe 0.930, right? Fe 0.930. So you'll get 15.5%. Is it 15.05? Should you check your answer once? That was 0.14 divided by 0.9, 0.93. So we are getting 15.05. Yeah, we are getting 15.05. Approximately 15% the answer we are getting. Yeah, correct. Right. So this is the question we have. Okay. So you should know this fact. This is a very important question. You can see it has been asked in J exam IIT 1994. Okay. But there is a correction here. Like this, the printing mistake basically. So what we are doing, we are just balancing the charge. Total charge should be 0. So we calculate the charge on iron, calculate the charge on oxygen, equate this to 0, and that is the answer. So this is not right. Okay, the question should be this, and we get this answer. Understood? Okay. Now the next concept here we are going to study is write down write down moles. Have you heard this term, mole? Yes. So what is a mole? How do you define mole? Mole is what? Mole is a quantity, basically, right? It is just a quantity. Like we have dozen. What is dozen? One dozen is equals to what? One dozen is 12 entity, 12 anything, right? 12 units, 12 pen, 12 pencil, anything you can have, right? So similarly, one mole is also a number, nothing more than that. One mole is also a number. What is that number? We'll see, right? But mole is nothing but an amount or a number. Clear? Now, how do we define a mole? What is the definition of mole? Write down. It is the amount of substance. It is the amount of substance which contains it is the amount of substance which contains as many entities as there are number of atoms present as there are number of atoms present in 12 gram of C12 atom. Okay, as there are number of atoms present in 12 gram of C12 atom. Done, all of you? Correct. Now, the number of atoms present in 12 gram of C12 atom is equals to 6.022 into 10 to the power 23 atoms present in 12 gram of this carbon sample. Okay, 6.022 into 10 to the power 23 atoms, correct? Now this atom, this number is determined experimentally. Okay, determined experimentally. The name of the scientist is Avogadro, who found out this number, right? And hence this number we also call it as Avogadro's number. And represented by N subscript A, Na, right? Avogadro's number Na, right? So 1 mole is the unit defined by the number, and this number is the number of atoms present in 12 gram of C12. So 1 mole is nothing but what? 1 mole is nothing but 6.022 into 10 to the power 23 entities. This is what 1 mole. It is exactly similar to dozen, or if you know this particular term also, which we call it as 1 gross. 1 gross is what? 1 gross is 12 dozen, means 144 entities, right? Units. Okay. So all these terms are defined. Dozen means 12, gross means 144. Similarly, mole also means a number which is this. Correct? Why we use this term? Why we define this mole? Because if you want to write down write down the various data, right? So which one is easier to write? This one or this one? 1 mole or this number? Obviously 1 mole, right? 1 mole is easier to write. That's why for the ease of ourselves, we have defined this quantity by a term which is a 1 mole. Did you get this? Right? Any doubt? Clear. Fine. So you must have studied this in 10th standard also. And there, there they have given 6.023 into 10 to the power 23. Yes or no? Is it 6.023 in the book? Right? So that 23 we won't use here, right? However, the difference is at the third decimal point, right? That won't change your answer much, right? But here in 11th grade, all books, if you see, they have taken 6.022 into 10 to the power 23. So from now onwards, we'll use Avogadro number at 6.022 into 10 to the power 23. Right? First, we'll write 22 and then we'll write 23. Okay, don't get confused. Okay, this number is the Avogadro number represented by the symbol 1Na. Right? So if I ask you 1 mole of electron, this means how many electrons? 1 mole of electrons means how many electrons? 6.022 into 10 to the power 23 electrons, right? Like it's very simple. If I ask you 1 dozen electron, you would say 12 electron, right? Similarly, you have to say this one also. Mole means that number. That is it, right? 1 mole molecule. 1 mole molecule means how many molecule? Na molecule. Na is nothing but this number. Na molecule. 1 mole pen means Na pen, right? This is it. Mole means this number. That is what you should keep in mind. Okay. Now, if I ask you, we have 1 mole of oxygen molecule, of O2 molecule. How many oxygen atom we have in this? Only 2. Is it only Na? Yes, Shraddha, very good. 2 into Na, right? Because you see 1 mole of O2 molecule means how many molecules? Mole means this number. Means we have NaO2 molecules, right? And in 1 molecule, we have 2 atoms. So these many molecules, how many atoms? 2 into Na, oxygen. Any doubt? Any confusion? No? Correct. Okay. So that's what I'm suggesting you. Mole means you have to think about that number. Whenever you see this term, it means that number you have to deal with. Fine. Now there are formulas with which we'll find out the number of moles. So what are those formula you'll see? Write down the formula. number of moles. This is equals to given mass divided by atomic mass. Will write if atom is present. If molecule is present, then we'll write molecular mass. This is one formula. Number of entities divided by Avogadro number. That is Na. Volume occupied by the gas divided by molar volume. Molar volume is represented by Vm, molar volume. But this relation, the third formula, is true only at STP. Only at STP. This formula is applied only at STP. What does this STP stand for? It is standard temperature and pressure. Standard temperature and pressure means the temperature should be 0 degrees Celsius or 273 Kelvin. Pressure is 1 atmospheric, ATM. The unit of pressure, 1 atmospheric. Okay, so whenever it is written STP, it means temperature is this, pressure is this. That is what it means. Okay. Okay. Now you see how did we get this formula? Okay. First of all, the first formula you see, given mass by atomic mass. Suppose I have taken carbon atom, right? What is the atomic mass of carbon? 12, right? I'm taking 12 gram. Gram atomic mass is 12 gram. Now, if I take 12 gram of sample, means how many moles of carbon atom we have? In 12 gram of sample, how many moles of carbon atom? 1 mole, because given mass is 12 gram and atomic mass is also 12. So it is 2 mole. If we take 24 gram of carbon, then it is 2 mole, right? 48 gram of carbon, then 4 mole, right? So given mass means what? We can take whatever we want, right? Given mass means whatever mass given in the question, or we can take whatever we want, but atomic and molecular mass is fixed, right? It means what we can say, if you take the atomic mass or molecular mass of a sample of a substance, then it means we are taking 1 mole of that substance, right? So what we can write here, that's why the formula is this, and we can write atomic or molecular mass signifies 1 mole of that substance. Is it fine? Right? Okay. Second formula is easy. You can understand this easily. Avogadro number is equals to 1 mole. So number of entities that you are taking divided by the Avogadro number is the number of moles. It is as simple as that. If you take 24 pen, then how many dozen we have? This entities, the given number of entities divided by the entities, which is equals to 1 dozen, that is 12. So 12 is 1 dozen and Avogadro number is 1 mole. That's why the number of entities divided by Avogadro number is the formula we have. Simple. Any doubt? All of you, please. Keep interacting, otherwise I won't understand whether you are getting it or not. However, these are not difficult, right? Yeah, that's all. Yeah, thank you. This one is important, right? To understand this, okay, we are going to see 2-3 points here, then we'll understand this particular concept. Okay, see, actually, you must be familiar with the coordinate system, right? You know what is a coordinate system? Right? Suppose if we take an x, y, and z axis like this, right, and we try to define the position of an object with respect to this axis, right? Suppose this is x, this is y axis, this is x axis, and this is z axis, right? So you must be familiar with this coordinate system, right? This coordinate system, we use this coordinate system to specify the point of an object, right? Position of an object. Okay, all these, you know, the army of like the army, they use this coordinate system only to to locate their target. They fix the coordinate in the computer and then they launch the missile or whatever it is, right? So the coordinate system is used to define the position, to define the location, exact location of an object, right? Similarly, if you have to define the position of a gaseous system, you see the third one that I have written over here, okay, you have to listen to me for further 10 minutes, okay, very sincerely. This is defined only for gas, because I have written here volume occupied by the gas. Sorry, I have missed over here, by the gas. So this is applicable only for gaseous system, only for gases. Right? So here you see what happens. To define the position of a gas, right, we also have some variables. For an object, like suppose I have to locate my location, right? So for an object, we use 3 different, axis, x, y, and z axis. And this coordinate is what? This coordinate is, suppose I have written 2, 4, and 3. It means you have to go 2 units on x-axis, then 4 units on z-axis, and 3 on this y-axis, and 3 on this z-axis. Right? Or if you take 2 variable here, then what we can say, probably with this we can understand it easily. Suppose I am taking 2 variable here, right? 2 variable here, 2 and 4. So what do you mean by this? You see, on x-axis you have to go 2 units, and y-axis 4 units. The position that you get, that is the location, okay, whose coordinate is 2, 4. Correct? Similarly, for gaseous particle, we also define the position of a gaseous particle with the help of variables, right? What are those variables? Variables are, we are talking about gases now, right? So variables with which we define the position of a gaseous particle is pressure, right? Temperature and volume. Pressure, temperature, and volume, right? Suppose we have a position of an object, and that position is this. We have position A, and this is position B, right? So at these 2 positions, we have a definite pressure PA, a definite volume VA, and a definite temperature TA at position A. This point, the pressure is PV, VB, and TB. Two different points cannot have all three variables same, not possible, right? Okay, so at one point we have one set of these variables PA, VA, TA, PV, TB. Any variables, if it is changing, right, it means the gas is changing its state. Are you getting it? If PA from PA to PV you are going, it means the gas is changing its state. VA to VB you are going, gas is changing its state, right? State means position basically. State means not like gas to liquid, right? It's position. Clear? So now these three variables we can correlate with each other for a given amount of gas. Okay. So for a given amount of gas, the three variables are related with each other by the expression, and this expression you must have done, that is PV is equals to nRT. Have you done this? Have you seen this expression before? Right? PV is equals to nRT, which is the ideal gas equation, and we also call it as equation of state. Equation of state, because it defines the position of a gaseous particle, what position it is present, right? What is the state of that gaseous particle? Equation of state, ideal gas equation we also call it, right? Because the ideal gas follows this equation. Okay, but we are not going to discuss ideal gas and other things. For that we have a separate chapter. We'll discuss those things over there, right? So this is PV is equals to nRT. When we talk about amount, right here, see, when we talk about amount, it means we are talking about the number of moles. We are talking about moles or mass or anything, like, because mole we can always convert into mass, right? So for a given amount of gas, means for a given number of moles, right, we can write down the relation of these three variables by this. PV is equals to nRT. Let me tell you, we have proof of this also. How do we get this equation? We have that proof, okay, from various gas law, but for that we have a separate chapter, that is gaseous state. We'll discuss that into that particular chapter. Here you just need to know that PV is equals to nRT is applied only for gases. It is the equation of state. We have three variables in this: pressure, volume, and temperature, which is related with each other by this expression. Now, PVT, you know, it is pressure, volume, and temperature. N is what? N is the number of moles. Write down. N is the number of moles. R is the universal gas constant. Universal gas constant. So the value of R you must memorize. It is 8.314 joule per mole Kelvin, or 0.0821 atm liter mole Kelvin. Keep this in mind that we are discussing this to understand the third formula of number of moles. Okay. Okay. Now you see, if I ask you, the volume occupied by, write down this, volume occupied by 1 mole of a gaseous substance at STP, right? At STP. So here you see, we need to find out the volume, that is V, at STP by 1 mole. So when it is STP, so at STP we know temperature is 0 degrees Celsius, right? You always remember, for this equation, temperature we use in Kelvin. So 0 degrees Celsius is 273 Kelvin. Always we write temperature here in Kelvin, right? Pressure, we also know pressure is 1 atmospheric. R value we know, so constant, and that is 0.0821 mole per liter Kelvin. Or mole liter, right? So I've written liter. So this is mole Kelvin. Okay, this is the unit we have. The value of N is also given in the question, that is 1 mole. So with the help of this equation, we can find out B from this. Yes, so we get 22.4 liter. Okay, so when you substitute all these terms here, so the volume we get, right? So it means what? At STP, 1 mole of a gas occupy 22.4 liter, right? So write down at STP, yeah, approximately we use 22.4 kilo. That's fine. Write down the point here. At STP, at STP, 1 mole of a gas occupy 1 mole of a gas occupy 22.4 liter. 22.4 liter. Okay, that's why you see in this formula what we have written here, volume occupied by the gas divided by molar volume. Molar volume is what? It is the volume, write down this term also, molar volume. It is the volume occupied by one mole of a gas. Right? So whatever the volume occupied by one mole of a gas is called molar volume. Right? So what is the molar volume here at STP? Molar volume at STP Vm is, just now we have calculated 22.4 liter. So if the condition given at STP, then the given volume of the gas divided by the 22.4 liter gives you the number of moles of that gas. Now do you understood all the three formula? No doubt. Okay. Try this question. Out of 5 moles of CO2, 10 to the power 23 molecules have been removed. Calculate the number of moles of CO2 left. Try this question. Done. .83. No, it's not. Shambo, it's not 5 into that. 3.83 is not correct. Yes, 4.83 is the correct answer. Right. You see, the question is, we have CO2 molecules, right? and the amount of CO2 we have 5 moles of it. 5 moles of it. And out of 5 moles of CO2, we have removed 10 to the power 23 molecules, correct? So the question is, we need to find out the moles of CO2 left. Moles of CO2 left. You see here we have moles and we are subtracting molecules. This is not possible, right? So either you have to convert this moles into molecules or molecules into moles, right? Now, since the question is we need to find out answer in terms of moles, right? So I'll just convert this molecules into moles, correct? So these many molecules equals to, we know number of entities divided by what? Avogadro number. So 10 to the power 23 divided by 6.022 into 10 to the power 23 moles we have here. These many moles have been removed, which is further becomes 1 by 6 approximately I am taking. 6.022, I am assuming this as 6. We can do this assumption based on the question. Okay, if the so we convert the moles into molecules. Yes, yes, yes. We'll get the same answer. But the thing is, again, molecules you have to convert into moles. We'll get the same answer because question is what? The number of moles of CO2 left. Okay, we need to find out the number of moles of CO2 left. Okay, that's why I have converted molecules into moles, not moles into molecules. Right? If the question is about molecules, then I would have converted this moles into molecules, correct? One point. Another point is this 6.022, this 6.022, we can take the approximation as 6. That is also fine. So obviously we have 5 moles. 1 by 6 moles have been removed. So how many moles left? The moles left is 5 minus 1 by 6. That is 29 by 6, which is 4.833 moles have been left. I hope it is clear to all of you. Correct? Okay. There are 5 questions. Try this one by one. And give me the answer all together, right? It's A or C, Raghav, 16th one. You have given two different answers for the same question. Okay. You know the atomic weight of zinc? The atomic weight of zinc, what is that? The atomic weight of zinc is 95. Use that. Any other information you want? You can ask me if you have any doubt, like quick help if you want. Okay, so Titiksha has done. 13th one, how many of you have done? Question number 13. Rohan. Okay. Okay. Okay, so have you tried all the 5 questions? Arshit. Archit, 12th one is not there. I think it's 13th, right? That's what you mean. Okay. Shall we start? Okay, I'm starting this. I think all of you have tried, right? Okay, let me know, guys. Shall we start this? Start the discussion? I will tell the answer first for the 5 question, correct? Yeah, I will tell the answer first, and you tell me how many questions you got right. Okay, just you can write down the number. Suppose you have got 5 correct, you can write 5 over there, right? And then we'll start discussing it quickly. So question number 13, B as in Bangalore is correct. Option B. Question number 14. Question number 14, the correct answer is A as in Ahmedabad. Ahmedabad. 14 is A. Then question number 15. Question number 15 is C as in Chennai. Yeah, I'll do all the questions I'll do. Let me tell you the answer first. Question number 15 is C as in Chennai. Question number 16 is is again A, that is Ahmedabad. 16th one is A. 17th one is C as in Chennai. 17th one is C as in Chennai. So Vaishnavi got 4 correct. What about others? So 5. Arshit got 5. So 5 is the 100% marks. Okay, Shraddha got 4. Kiran got 3. Akshat 4. Okay, fine. That's not bad. That's not bad. All of you have got the decent score. 3, if you correct out of 5 at this level, it's fine. 3, 2, it's fine. That's not a big deal. Okay. Now we'll start discussing it. Okay. The 13th one, you see, that is the, if I give you this particular information, you would have solved this question. Okay. How many of you got correct 13th one? 13th one? Okay. Okay, fine, fine, fine. So why, Kiran, you got wrong? Because, you do not know the reaction. Okay. Suppose in this reaction, I have given you this information that MgHCO3 is the magnesium bicarbonate, and this magnesium bicarbonate dissociates as this. Dissociates as MgCO3, water, and CO2. This is the reaction we have. Now, with this reaction, you can solve this question easily. Okay. Some of you maybe you know this reaction, but you could not do this because of you do not know how to do this. Some of you maybe you do not know how this magnesium bicarbonate dissociates, right? So those who do not know this particular information, or those who know also, you have to understand one thing over here, that method is not that difficult over here, but this prior information, if you do not have, that how this magnesium bicarbonate dissociates, you won't be able to solve this question, because this question is based upon the ratio of this, the molar ratio of this reactant and product. Okay. Now what we can say here, you see, can we say 1 mole of magnesium bicarbonate, 1 mole of magnesium bicarbonate gives 1 mole of CO2? Can we say that? So it is a unitary method basically you have to apply in this chapter. 1 mole of this gives 1 mole of CO2. We need to find out the volume of CO2 gas evolved at STP. What information we have? 1 mole at STP is equals to what volume? 1 mole of gas at STP occupies what volume, guys? Occupies 22.4 liter, or 22400 milliliter. This is what the relation we have. We know this fact, right? So if we find out the number of moles, then by unitary method you can find out this question. Yes or no? We can say 1 mole occupy this, so 10 mole occupy 224 liter, 100 mole occupy 2240 liter, like that. So it is just a unitary method. So if you know this number of moles of this gas, that is CO2 here, you can find out the volume occupied by the gas. Correct? How do we find out the moles? You see, the mass of magnesium bicarbonate is given, right? Volume of carbon dissolved by this 7.3 gram of this. So this mass is, it is given here 7.3, just a second. It is given as 7.3 gram, right? This is 7.3 gram we have. Okay, so this gram is equals to how many moles? Because we heat this, we'll get the product. This sign means we are heating it. This sign, the small triangle you see here, means we are heating it. Okay, so 7.3 gram divided by the molecular mass of MgHCO3 gives you the number of moles of MgHCO3. So could you tell me the molecular mass of MgHCO3? It is 146, correct. It's 146, 24 for magnesium, and all other, hydrogen, carbon, and oxygen, right? 146. So this divided by 146 is the number of moles. So how many moles we get? We get 1 by 20, that is 0.05 moles. Yes or no? Is it 0.05 moles? Okay. Now 1 mole gives you this ml of volume. So 0.05 moles gives 22400 into 0.05 moles. Because you see one more thing here, 1 mole of magnesium bicarbonate gives 1 mole of Cl2. So these many moles gives 0.005 moles of MgCO3 gives, MgSCO3 gives 0.05 moles of CO2, right? So 1 mole of CO2 occupies this, so these many moles occupy this. You can solve this expression, we'll get the answer. Unit you must take care of. Okay. Now, question number 14. Question number 14, you see the amount of zinc atomic weight is given 65, necessary to produce 2 to 4 ml of H2, right? 2 to 4 ml of H2 by the reaction with an acid. So again, you see any reaction you consider. Suppose I am considering H2SO4. This question again based upon the information about the reaction. This gives you ZnSO4 plus hydrogen gas evolves into this. The reaction is already balanced, right? Again, we can say 1 mole of zinc gives 1 mole of H2. The amount of zinc necessary to produce 2 to 4 ml of H2. So at STP again it is, no? Okay, it is not mentioned here, but in the question it should be mentioned that the reaction is at STP. Because this, without this information, we cannot say. Right, at STP, you must consider this. It is understood, right? So at STP, we know the volume by H2 is given, that is 2 to 4 ml, right? So if I write down the number of moles here of H2, moles of H2, the volume occupied by H2, that is 224, divided by the volume at STP in ml, that is 0.01 mole of H2 we have. Now the number of moles of H2, N of H2, should be equals to the number of moles of zinc, and that would be equals to 0.01 mole, right? So 0.01 mole is equals to mass divided by atomic mass of zinc, that is 65 given in the question. So mass is equals to, that is required to produce this volume of H2 is 0.65 grams. Any doubt in this? Anyone, any doubt in this? No? Both questions are based on the same concept at STP, and you should know this information. In some of the reaction, what happens, the molar ratio is not 1:1. Like this 1 mole gives 2 moles of this. So in that case, you have to again apply the unitary method. 1 mole gives 2, so 10 moles gives 20. Like that will find out the number of moles. Where did I get 0.1? 0.01 you're talking about, Harshal. Which one, Harshal? 14. It is 0.01, you see, it is 0.01. Volume of, see, the mole formula is what? We have used the third formula of mole. Third formula of mole, you see, volume occupied by the gas divided by 22.4 liter. So 224 ml occupied divided by 22400 ml of it. This gives you the number of moles. Clear? Okay. Now the next question, 15th one. The number of atoms in 4.25 gram of NH3 is approximately. Okay, so I'm going to the next page. Number of atoms in 4.25 gram of NH3. NH3 we have 4.25 gram. 15th one. Number of atoms. Okay. So could you tell me in one molecule how many atoms are there? Anyone? In one molecule, how many atoms are there? There are 4 atoms, correct? 3 hydrogen atoms and 1 nitrogen atom. So if they're talking about atoms only, so we need to, consider all the atoms. Okay. So what I'm telling you, that one molecule has 4 atoms total. So 10 molecules will have 40, 100 molecules will have 400, and so on. So point is, if you know the number of molecules, you can find out number of atoms. Yes or no? I want CLR. If you're getting it, I want CLR. Otherwise, it's very difficult for me to proceed. Okay, I want you to understand each and every concept. Okay, so one molecule is 4, 10 molecule will be 40, 100 will be 400. So basically the question reduced to what? Question reduced to the number of molecules. So if you find out number of molecules, we can find out the respective number of atoms. How do we find out number of molecules? We know 1 mole is equals to what? We know this fact that 1 mole is equals to how many molecules? Guys, 1 mole is equals to Na molecules. 1 mole of molecules if you take, it means we have Na molecules into that, right? So now if you know the number of moles, you can find out number of molecules. If you find out number of molecules, you'll get what? You'll get number of atoms. That is what the steps we have. How do we find out number of moles? For that, mass is given. So given mass divided by molecular mass. So what is the number of moles of ammonia? Tell me. It is given mass 4.25 divided by the molecular mass of ammonia is 3 plus 14, that is 17. Could you tell me what is this value? .25. So we have 0.25 moles, right? So 0.25 moles means 0.25 into Na molecules. 0.25 into Na molecules means 0.25 into Na into 4 atoms. Hence, the answer for this question is Na atoms. 6.022 into 10 to the power 23. Clear? No doubt. Right. One more thing I'll suggest you what? Yeah, just a second, Supi. One more thing I'll suggest you what? That you write down the expression in terms of Na only. Don't write 6.022 into 10 to the power 23. Keep it as Na only. When you get the final expression, then you can substitute if it is required. Otherwise, let it be in terms of Na only. Yeah, right. So another thing is, Suti, like this, I'm repeating this. See, with this given mass, we can find out number of moles. That is fine. What we need to find out, we need to find out the number of molecules of NH3, because we know in one molecule there are 4 atoms present. So if you know the number of molecules, you can find out the respective number of atoms multiplied by 4, right? So these many moles in this gram we have used the formula and find out the number of moles. 1 mole is Na molecule, so these many moles is this into Na molecules. Now you see, one molecule has 4 atoms, so these many molecules has how many atoms? This into 4, that is 1 atom over here. Na atom we have over here. Answer is Na atoms. Any doubt? No? Okay. Last 2 questions. Question number 16. Let me just see the question first. So we are done with this. We are done with 14. We are done with 15 also. 15 is approximately this we have to take. What is the answer given for 15th one? What did I say? Yeah, what is the answer given? Yeah, C is not right. Okay, answer is this. Okay, A is correct. Okay, then there may be some mistake. A is correct. Okay, correct it. Okay, the number of molecules. This one we also have done, right? That is 0.25 into 0.25 moles. So 0.25 into Na. What is that value we are getting? 0.25 into Na. Something around 15. So I think this is the answer. Either A or D. Tell me the answer. 1.5. So this is the answer we have done. Just now we have done this. The weight of single atom of oxygen. How do we do this? Any idea? Single atom. Yes, yes, Ruchita, very good. So 16 gram, the atomic mass of oxygen has Na atoms. So one atom is 16 by Na. Just you need to solve this. So 16 by Na, you will get the answer. Which option you are getting? Correct. C is right. Okay, no doubt. Okay, let's move to the next concept. Okay. Have you heard the term gram atomic mass? See, the last one, Meghna, was what? The question is, what is the mass of one oxygen atom? That was the question. Let me see the question again. The question was the mass of a single atom of oxygen, correct? Single atom of oxygen. This means what? See, the oxygen atom, the mass is 16 gram. and we'll discuss this thing over here just now, that 16 gram means the atomic mass of any substance, it is the mass of Na atoms, right? Atomic mass is the mass of Na atoms. Means the mass of Na atom of oxygen is 16 gram. So mass of one atom is what? 16 by Na. And that is what you need to solve. You'll get option C. Okay. Write down gram atomic mass. What is the mass of carbon atom? Could you tell me? The mass of carbon atom? 12. What 12? 12 gram. 12 gram. Okay. 12 gram. 12 gram. What is the definition of gram atomic mass? So when the mass expressed in gram, it becomes gram atomic mass, correct? That is what you know. Yes, that's what I said, Gayatri. When the mass expressed in gram, it becomes gram atomic mass, correct? But that is not the correct, understanding of this concept. Okay, it is not, yeah, in 10th grade, I understand. It is given in the book, when the atomic mass expressed in gram, it becomes gram atomic mass. But that is not, you should leave that definition now, right? What you have to understand here, suppose if I ask you the atomic mass of carbon, most of you have answered 12 gram. I was asked, means I asked you the atomic mass of carbon. You said 12 gram, which is wrong, technically wrong. However, to solve the question, we take atomic mass as 12 gram, but there, we are considering atomic mass as gram atomic. To solve the question, gram atomic mass, will consider same, but there is a small difference, technical difference. The atomic mass of carbon is always 12 AMU. It is not 12 gram. First thing is that, right? Then what is this 12 gram? That is the next question, right? So 12 gram is what? That is what we are going to see. So 12 gram is the gram atomic mass. It is not the atomic mass. 12 gram is gram atomic mass. 12 AMU is the atomic mass of carbon. Now, what is the definition of the gram atomic mass? All of you write down. It is the mass of Na atoms of any element. Na atoms, Avogadro number. It is the mass of Na atoms of any element. Okay. So for any elements, if you have to find out the atomic mass, what you need to do, you need to collect any such atom, any atoms of that element. Suppose for nitrogen, you have to find out. So what we'll do, we'll collect any nitrogen atom, Na nitrogen atom, and we'll find out the weight of this. For carbon, what we'll do, again we'll collect Na carbon atom, and we'll find out the weight of that. That will be the atomic mass, gram atomic mass of carbon. Oxygen, what we'll do, Na oxygen atoms. We'll collect Na oxygen atom, and we'll find out the mass of that. That's why you see in the previous question, the one that some of you have asked, probably Meghna or some of you have asked just now, This one, I have taken 16 gram, and what I took here, 16 gram contains atomic mass is nothing but the mass of Na atom. Means in 16 gram of the sample, there are Na atoms present. So what is the mass of one atom? That's what we did, right? So here also we have the same thing. You see, any atom, if you have to find out the gram atomic mass, you collect Na atoms of that element and find out the weight of that. Okay. So can we conclude one thing here? The atomic mass of any element consists of equal number of atoms, and that number is Avogadro number. Can we say that? Yes or no? What I said here, see, what I said, atomic mass of any element, consists equal number of atoms, and this number is equal to the Avogadro number. Right? This is what we can say. This understanding you must have. Okay. Now you see we have taken the example of carbon. Okay. So carbon, the mass of carbon atom is 12 AMU. Can we convert this into gram? Yes, we can. We have seen the relation last class. 1.66 into 10 to the power minus 23 gram is 1 AMU. So we'll multiply with this, right? So this is the absolute mass of one atom. Mass of one C12 atom. Absolute mass means the mass in gram, right? So this is the mass of one atom. So what is the mass of Na atom? Into Na, that is 6.022 into 10 to the power 23. Now this product is coincidentally coming out to be as 1. And that's why the whole thing is equals to 12 gram. Since the mass of any atom is nothing but the gram atomic mass, gram atomic mass. So what happens here, you see, the atomic mass of carbon was 12 mu. Gram atomic mass becomes 12 gram. That's why in the book it is written, when the atomic mass expressed in gram, it becomes gram atomic. But actually the definition is what? It is the mass of 1 mole of an atom, or the mass of any atoms. Any doubt? Okay. Gram atomic mass, we also call it as gram atom. Okay. Gram atomic mass and gram atom both are same thing. Write down, it can also be defined as the absolute mass of Na atom, or 1 mole of atom. The absolute mass of 1 mole of N atom. It can also be defined as the absolute mass of 1 mole of an atom. Okay, fine. Now we have one more term, we call it as gram molecular mass. Gram molecular mass and gram atomic mass are exactly same. The only difference is in case of gram molecular mass, we are dealing with molecule, and here we are dealing with atom. So the gram molecular mass, the definition if you see, it is the mass of any molecules of any compounds. Okay, exactly same. So I'll just give you the theory here and then move on. Okay, you know already all these things. Write down the heading gram molecular mass. Write down, it is the mass of any molecules of any compound. It is the mass of Na molecules of any compound. Okay, for example, you see I am taking H2SO4, so its molecular mass is 2 into 1 plus 32 into 1 plus 16 into 4, which is 98 AMU. The molecular mass is this AMU, right? Convert this into gram, it is 98 into 1.66 10 to the power minus 23 gram. Okay, so gram molecular mass is what? Is 98 into 1.66 10 to the power minus 23 into 6.022 10 to the power 23. This product is again 1 and it becomes 98 gram. Right, so in gram it is gram molecular mass or gram atomic mass. In AMU it is the atomic mass. If somebody asks you what is the molecular mass of H2SO4, it is 98 AMU. Right, what is the molecular mass of H2SO4? It is 98 AMU. Okay, it is not 98 gram. So there is a difference in this, right? Difference in the understanding, but yes, for solving questions, we consider 98 gram as 98 AMU. Okay, that's what that is. 10, oh yeah, it's 10 to the minus 24. It is 10 to the power minus 24. Did I write there also? Let me check. Yes, correct. This is 24. Yeah. Okay. This is the gram molecular mass. Okay. One question you write down. Calculate the number of electrons. Calculate the number of electrons present in 1.6 gram of methane. Okay. Calculate the number of electrons present in 1.6 gram of methane. 1.6 gram of methane. So please check your calculation once. Okay. See this. The mass of CH4 is given, that is 1.6 gram, right? So number of moles of CH4 is given mass divided by molecular mass, that will be 0.1 mole. So number of molecules is equals to 1 mole is Na, so this is 0.1 into Na molecules, right? And 1 molecule of CH4 has 6 plus 4, that is 10 electrons. See, if they ask you number of electrons, you just add the atomic number, because atomic number is the number of proton, and number of proton and number of neutrons, electrons are equal, correct? So that we can say 6 plus 4, 10. So one molecule has 10 electrons. So these many molecules have how many electrons? Number of electrons total is what? 0.1 into Na into 10. So that will be Na electrons. Correct? If they ask you the number of electrons present in 0.28 gram of N3 minus ion. Try this one. Number of electrons present in 0.2. Tell me what is the answer? Point 0.2 into Na. Okay. I think that's correct. Akshit. All of you are getting 0.2 into Na. Okay. So same thing. First of all, in this ion, there are 10 electrons present, right? 7 plus 3 negative charge means 3 electron you have added, right? 3 negative charge means 3 electron you have added onto this. So 7 was already present, 3 we have added, so total it is 10. Now in this mass, the number of moles N of is equals to 0.28 divided by 14, which is 0.02. Right, so these many moles has 0.02 into Na N3 minus ion, and one ion has 10 electrons, so these many will have 0.02 into Na into 10, which is 0.2 Na electrons. Okay, understood? Okay. Next we'll see, write down the heading. Avogadro's law. Two quick things here. It is applicable only for gases, right? Condition is pressure and temperature are constant. Okay, pressure and temperature are constant. The statement to write down, write down the volume occupied by the gaseous molecule is directly proportional to the amount of substance present to the amount of substance present to the amount of substance present at a given temperature and pressure. At a given temperature and pressure. Okay. Two things, like I said, applied only for gas, pressure and temperature must be constant, right? So if I write down the gaseous law, which is PV is equals to nRT. Now here you see in this particular thing, pressure and temperature, we have to assume this to be constant. R is universal gas constant. So we are left with what? Volume and number of moles. That's why at constant temperature and pressure, volume is directly proportional to the number of moles, right? V is directly proportional to N. Okay, number of moles. So for two different amount, for two different amount, at same condition, we can write V1 by N1 is equals to V2 by N2. Correct? Is it clear? V1 by N1 is equals to V2 by N2. Can we write this? Further, if the gas is same, we can also write V1 by M1 is equals to V2 by M2, where M1 and M2 are the gas corresponds to this number of moles, N1 and N2. Is that another relation? Okay, this is the relation we have. Okay, now from this relation, we can also conclude 2 points here. Yeah, M is the mass. N1 mole mass is M1, N2 mole mass is M2. We can conclude 2 points here, you see. First case, what happens if they have equal number of moles, N1 is equals to N2, right? If they have equal number of moles, it means the gas has equal number of molecules. Right, 1 mole Na molecules to 10 mole 10 molecules. Equal number of moles mean equals molecules. This means what? At a given condition, if the moles of the gases are same, it means they must have the same number of molecules, equal molecules. Okay. Second thing, what we can say, if V1 is equals to V2, this is also we can consider over here also. V1 is equals to V2, then also we have the same condition. Gas has equal number of molecules. But if V1 is equals to V2 is equals to Vm, where Vm is the molar volume. What is molar volume? It is a volume occupied by 1 mole of a gas. Molar volume. Molar volume. Correct? Volume occupied by 1 mole of a gas. Right. So V1 is equals to V2 is equals to Vm. It means we have 1 mole, and 1 mole means the gas has Na molecule. Right? It means V1 is equals to V2 is equals to Vm. Again, we can write down the same condition. The gas has equal number of molecules, and the number is equals to Avogadro number. Avogadro number. Did you understand the 2 point? So this is a statement you write down. At a given temperature and pressure, Here write down after this. At a given temperature and pressure, molar volume of all gases molar volume of all gases will have equal number of molecules and this number is equals to the Avogadro number Na. This number is equals to the Avogadro number Na. Any doubt? Understood this Avogadro's law? Yeah, Shraddha, just we'll do one questions on this and then we'll take a break. Wait, we'll finish this off. So understood, guys, all of you? Just a second. Okay, write down this question. All of you copy down the question. Volume of NH3 left. Options are given. Try this. Okay, you're getting B. Sudhi is getting 43 point something. Okay, all of you are getting B. Okay, how do we do this? The volume is given. V right, V1 is given initially 44.8 liter, right? So 44.8 liter, it means the number of moles, so the number of moles is 2 moles here, because the condition is given, the condition left at STP, it is there, that is understood. So number of moles is 2 moles initially. So these many molecules have been removed. How many moles have been removed? So I'll write on moles left. That would be 2 minus 5 into 10 to the power 23 divided by 6 into 10 to the power 23. That is 5 by 6. So 12 minus 5, 7 by 6, and which is 1 point something. These many moles left. Okay. Now we can write V1 by N1 is equals to V2 by N2. So V2 we need to find out. V1 is 44.8 into N2 is 7 by 6. N1 is 2 into 6. So when you solve this, you'll get 26.13 liter. Option C. This is what you did, right? All of you? Okay. But actually, you know, one thing here, you don't have to do anything, all these things. Like, all these things are not required. Yeah, we can convert that into molecules. Why 22.4? The volume. Yes, that also we can do. That is right. We can do that. Yeah, it's fine. It's fine. It's fine, Meghna. Akshat, that also you can do. Correct. Okay. But actually, the point I'm trying to make you understand is this is the method. With this, you can solve. But the question that you get in the exam, it is a multiple choice question. You should get the answer, no matter what method is. By trick also, if you can get, that is also fine. Okay, you can save your time. You see what happens. The initial volume is 44.8 liter, and we are removing some molecules. So volume will increase or decrease. If we are removing molecules, then volume should increase or decrease. Decrease, right? So answer will be what? Answer will be lesser than 44.8 liter. Yes or no? Answer will be lesser than 44.8. Correct? And that is the only one option we have here. You have nothing to do into this question. Did you get this? Right? The point is, it is a multiple choice question, and you always keep this in mind that options are also half of the information. Right? Question is nothing but it is a set of information. You have to, you have to get some other information with the help of concepts and other formulas. Right? Options also half of the information we have. So halfway from the question side, halfway from the option side you go, you will get the answer somewhere in between. Right? So in this question, the answer must be less than 44.8 under any circumstances. If you are removing some molecules, then volume must be less than 44.8. Then whatever the answer it is, whatever the option it is given, which is less than 44.8, if it is only one option there and only one correct it is there, then we have to go with this option. Suppose in this question, 26.13 is not given, but it is given 30 liter. And all three options are same. Only option B is 30. Then also we'll go with this. However, the value is not correct. But that is the most appropriate answer according to the concept. Are you getting my point? Okay, no doubt. Okay, fine. We'll take a break now. We'll resume the class at 6:30, 6:35. Okay. Take a break. We'll resume at 6:35. Yeah, take a break, guys. Hello. Yeah, am I audible? Right? Hello. Can you hear me? Yeah. Others, can you hear me? Others, Raman. Yeah, there was a power cut for a few minutes. I was out of the meeting. I have rejoined it again, but yeah, like others has become the host now. Just a second, guys. Just let me fix this. Give me just a second. Yeah, it's fine now. Now, can you hear me, guys? All of you? Yeah. Thank you, others. Okay. Thank you. So we have discussed about Avogadro's law. One question also we have seen volume and amount relation. Okay. The next thing we have to understand here is right. Next thing, write down density. We'll talk about density. Have you heard a term like vapor density? Okay. Density is defined as mass divided by volume. Okay. Represented by small d or rho. This we call it as rho. Okay. So density is what? It is a ratio of mass and volume. So unit, if you see, it is kg per meter cube. We can also write gram per ml CGS system, or gram per cubic centimeter. Cc is the cubic centimeter. 1 kg per meter cube is equals to 10 to the power minus 3 gram per ml. This is the conversion we have. You can easily convert this and you'll get this expression. So unit conversion also you should know how to convert the unit. 1 kg per meter cube is 10 to the power minus 3 gram per ml. Okay. 1 cubic centimeter is also 1 milliliter. Same. One meter cube is 1000 liter. Is 1000 liter. Okay. No, it's 10 to the power 3. Shraddha, you see this? We can convert this. You see, 1 kg per meter cube is what? 1000 gram in the numerator, and 1 meter cube is 1000 liter, and 1 liter is 1000 ml. So we get 10 to the power minus 3 gram per ml. Correct? Understood, Shraddha? Okay. So this is the units and density we have. Okay. Now there's a term called relative density. Relative density. Relative density means what? It is the density of one substance with respect to other substance. That is relative density, right? So density of one substance with respect to other, right? That is relative density. Relative density is what? It is actually RD, relative density. It is the ratio of, suppose, density of, we can write water with respect to air. So this is the relative density. So since we have ratio of density, this has no unit. Okay, it is unitless. No unit, correct? In the denominator, if you take hydrogen gas here, right, then the term becomes vapor density. Okay. So vapor density is written as Vd. Write down. It is the density of any gas. It is the density of any gas with respect to the density of hydrogen gas. With respect to the density of hydrogen gas. Okay. So Vd is defined as the absolute density of a gas divided by the absolute density of H2 gas. This is vapor density. Now we can find out a formula for this, and that formula is important. Okay, so you see, how do we find out the formula? We know the relation, that is PV is equals to nRT. So further we can write this as PV is equals to number of moles is mass by molecular mass of the gas. This is the molecular mass of the gas into RT. Number of moles is mass divided by molecular mass. Absolute density is, see, one is relative density, right? Absolute density is density itself, right? It is not relative. It is the density of the substance. So you can write simply density or absolute density. That means the same thing, right? The absolute density, you can say it is independent of the other substance. Means the absolute density of water is independent of whether you calculate that density with respect to air or with respect to any other substance. Okay. Yeah. So this is the formula. Number of moles is mass by molecular mass of the gas. Now you see, this is volume, this is mass. So if I write down this expression as P into molecular mass of the gas, just cross multiply this. That would be equals to mass by volume into RT. So mass by volume, this is what? This ratio is what? This ratio is density. Right? So density becomes what? D is equals to P into molecular mass of the gas divided by RT. This is the formula of density. Okay, D is equals to PmG by RT. Now this formula will use here. So what we can write, Vd is equals to vapor density, Vd is equals to pressure into the molecular mass of the gas divided by RT, and this whole divided by pressure into the molecular mass of hydrogen gas by RT. Is it clear? So what happens, you see this P and P gets cancelled, RT and RT gets cancelled. So we end up getting molecular mass of the gas divided by, for hydrogen is 2. So the formula becomes the molecular mass of any gas equals to 2 into its vapor density. Is it clear? So sometimes what happens in the question, they'll give you mixture of gas. Okay. No, pressure and temperature are assumed to be same. Means we'll have the condition where we have the same pressure and temperature for that gas and hydrogen gas. It's not like STP, same it should be. STP is also fine, but the general term is you should say pressure and temperature, the conditions are same for both the gases. Right? Okay. So that is one formula which is very important. Sometimes what happens in the question, they won't mention the gas, okay, or they'll give you the mixture of gas. When you have mixture of gas, then we cannot take, the vapor density of any, like, the molecular mass of any one gas, because it is a mixture. So in that case, what they do, they'll give you the vapor density of the mixture. So with the help of vapor density, we can find out the molecular mass of the mixture, and then we can find out the further things, whatever is required there. Okay. One more term we'll see, and then we'll discuss a question on this. See, the another term we have to understand is average molecular mass. Average molecular mass is the term we use again when we have the mixture of gases. When more than one gas is present, then the molecular mass of the mixture will be the average, right? That is average molecular mass. Write down, it is defined as it is defined for the mixture of non-reacting gases. Non-reacting gases. And this M average is defined as total mass of the mixture divided by the total number of moles. So mass divided by moles. See, actually, it is understood whenever when you solve some questions, you will have the idea here, Shraddha. Actually, what happens, it's not like all the gases are reactive, and it's not like they are unreactive. It depends upon the condition for the reaction, whether the condition is there or not. Okay, like I have discussed in the first class, if you remember, the combustion of carbon, right? We have oxygen present around ourselves, but the reaction is not taking place because the condition is not there. Okay, so whenever you get this question, like some vapor density is given or some other thing is there, means wherever you have to use this particular formula of vapor density or average molecular mass formula, then the condition is not sufficient for the gas to react. Then only this kind of problem is or the question is possible or correct. Okay, so that is the definition of this, that the gases must be non-reacting. That is the condition for average molecular mass. But when you get the question, you don't have to think about it, that whether it is reacting or not. Okay, you may get some questions in which you feel like, okay, these two gases can react with each other, but the thing is, there the condition is not sufficient enough for the reaction to take place. So at that condition, the gases are said to be non-reactive. Understood? Okay. So this is the formula we have. Now you see here, we have suppose three gases, mixture of three gases, right? G1, G2, G3. You can have more than this also. So mass of G1 is M1 and mole is N1. G3 is M3 and mole is N3. G2 is M2 and mole is N2. M average for this will be the mass of this M1 plus M2 plus M3. If you have more, then we can add those also here, divided by the number of moles N1 plus N2 plus M3. This is M average. Further, you can write this as in terms of molecular mass M1 plus M2 plus M3, okay, divided by number of moles is M1 by M1. This capital M is the molecular mass, M2 by M2 plus M3 by M. This is the formula we have for average molecular. Done.
Capital M is the molecular mass of that gas. Okay, M1 is the molecular mass of the gas G1, M2 is the molecular mass of the gas G2, and so on. Capital M. Okay. Now you see this question here. And the question is, we have a mixture of NO2 and N2O4. We have a mixture of this, and for this mixture, the vapor density Vd is given. That is 34.5. Obviously, there is no unit for Vd also, because the ratio of density, right? Vd is given. Calculate the composition of the mixture in percentage mole and in percentage mass. So percentage mole and percentage mass, both you have to find. Done? What happened? Are you not getting it? Yes. Okay. Now you see in this question, we need to find out mole percent and mass percent. Correct? Okay, so for mole percent, basically we need to find out how many moles of NO2 and how many moles of N2O4 present in this mixture. Correct? So first of all, the vapor density is given. So we can easily find out the average molecular mass. Yeah, 50 mole percent is correct, Rohan. Right. Right. So what is the average molecular mass, M average for this? That will be 2 into its vapor density, which is 34.5, and that is 69. Okay, 69. Now, this, since we have to find out the mole percent here, so what I am assuming, the gaseous mixture that we have into this of NO2 and N2O4, in this gaseous mixture, what I am assuming that we have NO2, N2O4, and the number of moles of NO2 is N. So this will obviously be 100 minus N if I am assuming the total number of moles is equal to 100. If 100 is the total mole I am assuming, so if NO2 is N, then N2O4 is 100 minus N. Okay. Why I am assuming 100? Because our percentage we need to find out. Okay. So whatever N we get here, that will be out of 100. So that automatically becomes the percentage here. Right. Now we have this formula of M average. We'll use this formula. The total mass divided by the total moles. So mass of NO2 plus the mass of N2O4. And this whole thing is divided by the total number of moles, which is 100 we have assumed. The mass of NO2 in terms of mole, if I write down, it is the number of moles of NO2 into the molecular mass of NO2. That is 14 plus 32, 46. Plus number of moles of N2O4 is 100 minus N, and molecular mass is 92 for N2O4 divided by 100. And this is equals to what? This is equals to 69, which we have already calculated. Just you need to solve this. The expression will be 6900 is equals to 46N minus 92N minus 46N. So 46N is equals to 2300. N is equals to 50. So the mole percentage of NO2 is 50, and mole percentage of N2O4 is again 50. So 50 mole percent we have. No, this will get cancelled. 92N minus 46N becomes 46N here. Minus I have written here, see. Okay. I have taken minus 46N, Shraddha. Final, when you solve this, you will get minus 46N there. 92N minus 46. Yes, Rohan, that's correct. Okay. So they have equal mole percent here, right? Equal mole percent. Now the mass percentage you have to find out. Then again, what you have to do? You assume the total mass as 100, right? Mass of NO2 you assume, that is M1, sorry, M only you write down, mass of NO2. Hence mass of N2O4 is 100 minus m. And then we'll have the formula of m average. 69 is equals to total mass we have assumed 100 by number of moles of NO2 plus number of moles of N2O4. This will be 100 divided by number of moles of NO2 will be mass divided by its molecular mass divided by its molecular mass, N2O4. That is 92. So when you solve this expression, you will find out M, and that will be the mass percent of this. Did you get it? Right? This is a method we can use. But I am not suggesting you to find out the mass percentage by this method. Okay? See, there is a better way, alternate way, and easy also with this. Calculation is less over here. Alternate method. See here, we have already concluded the fact that NO2 and N2O4 has equal number of moles. Yes or no? Equal moles. Then only they have 50-50 mole percent, no? Equal moles. You see, and this is, applicable for this kind of questions only. NO2, the molecular mass is 46. And N2O4, the molecular mass is 92. You see, the molecular mass is exactly doubled, right, into 2. Exactly doubled, right? But they have equal number of moles. So molecular mass is double for N2O4, but their number of moles is equal. It means the mass of N2NO2 we should take, it should be the double of N2O4, because you see moles is equal and moles is mass by molecular mass. Molecular mass of N2O4 is more, but the ratio is equal of NO2 and this. So the mass of N2O4 should also be in the same ratio of this, then only the mole ratio will be same. So if the mass of NO2 I am assuming M, so since molecular mass is twice of the molecular mass of NO2, hence the mass of N2O4 should also be twice in order to have equal number of moles. Did you get this? Did you get this, guys? Please tell me. Remember the point here that they have equal number of moles. Okay, for equal number of moles, because you find out the number of moles of NO2 here is m by 46. For N2O4 is 2m by 92, which is again m by 46. So hence the molecular mass is doubled. Hence the mass should also be doubled in order to have the equal number of moles. So we know the mass of NO2 and N2O4. So mass percentage mass of NO2 is what? The mass of NO2 divided by the total mass into 100. This is the m by 3. 1 by 3 into 100, 33.3% we are getting. Rest is what? Rest is percentage mass of N2O4. Okay. So it's not like we cannot do by this method also, but it takes some time and there are calculations also here, right? So here when we have equal number of moles, this method is easier. Did you understand this? No doubt, right? Okay, fine. Now, next we are going to see is stoichiometry. stoichiometry. Okay. In this section, we'll study about chemical reactions or a chemical change. So basically, we deal with the amount of product formed in a chemical reaction, right? What is the amount of product forms? What amount of reactant is required for a given amount of product? Those kind of stuff we'll try to understand over here, right? Now, to understand this, this section I have classified into two parts. Okay, chemical reaction. If we talk about, there are two different types of types of chemical reaction we have. Two different classifications we have. One is those chemical reactions which we can balance. Okay, and we call it as balanced chemical reaction, where the chemical reaction is given and we can balance those chemical reactions. Another one is unbalanced chemical reaction. You can ask me, sir, we know how to balance the chemical reactions. We can balance all reactions, right? Then why this thing we have unbalanced chemical reaction? Okay, so that answer you will get later on when you solve some questions. You will understand why we are discussing this two things. Okay, so in unbalanced chemical reaction, to find out the amount of product forms or any calculation, okay, we use first of all, what is unbalanced balanced chemical reaction? In balanced chemical reaction, the number of atoms remains constant on both sides. Number of atoms means what? Number of atoms of any element will be same on both sides of the reaction, reactant side and product side. Here the atoms are not constant. The number of atoms are not constant. Okay. So balanced chemical reaction, to solve this type of question where we have the balanced chemical reaction, we use the concept of limiting reagent. Limiting reagent. Limiting reagent will write as LR. Limiting reagent. Correct? In unbalanced chemical reaction, we'll use the concept of POS, means principle of, write down, principle of atomic conservation. In short, we call it as POAC. Okay, principle of atomic conservation. POAC will use. Okay, this is the two things we have to understand here: limiting reagent and principle of atomic conservation. Now let us understand with one example. I am taking an example of N2 gas plus 3H2 gas gives 2NH3. Could you tell me, if I take 1 mole of N2 and 3 mole of H2. First of all, the reaction is balanced, right? 1 mole and 3 mole of H2 if you take, then what is the amount of product formed? How many moles? will get 2 moles of this. If you take 2 moles of N2 and 6 moles of H2, what is the amount of product you are getting? 4 moles, right? 4 moles. Suppose we take 3 moles of N2 and 6 moles of H2. What is the amount of product we get? Now you see I'm getting different answers now. 2, 4, 3, different answers I'm getting. So why the confusion is? Because here the mole ratio is 1:3. 1 combines with 3 gives 2. The 2 combines with 6 gives 4. So 3 should combine with what? What should we have here? 3 combines with 9 gives what? 6 moles of NH3, right? But what happens if the mole ratio is not in the ratio of their stoichiometric coefficient? First of all, this number that is written over here, 1, 3, and 2, these numbers are called stoichiometric coefficient. Stoichiometric coefficient, right? So if the given number of moles is not in the ratio of their respective stoichiometric coefficient, in that case, we can apply the concept of limiting reagent. Are you getting it? So in that case, what happens? One of the reactants, not both. Listen to me very carefully. What I'm telling you, if the given number of moles is not in the ratio of their respective stoichiometric coefficient, then one of the reactant gives the product here, there. Means the amount of product we get, that depends upon one of the reactants, not both or all, right? If the mole ratio is not in the ratio of the stoichiometric coefficient. But here in these first two cases, what happens, you see, in the first two cases, the reaction is complete. There is no residue in this. It is a complete reaction because nitrogen and hydrogen completely converts into NH3. There is no more nitrogen or hydrogen left in this reaction in the first two cases. So this is a complete reaction. And in case of complete reaction, whether you consider nitrogen or you consider hydrogen, you'll get equal amount of product. For example, I'll show you. Suppose in the first case, I am trying to find out the mole of NH3 formed with respect to N2. So we know 1 mole of this gives 2. How many moles I have taken? I have taken 1. 1 mole gives 2. That is what I am getting here. Right? If you find out with respect to H2 in the first case, 3 moles gives 2. Again, 3 moles gives 2. So we are getting equal moles of product with respect to the two reactants N2 and H2. Even in the second case, you see the reaction is complete. So if you take nitrogen, 1 mole gives 2, 2 moles gives 4, correct? Hydrogen, 3 moles gives 2, so 6 moles gives 4. Again, it is correct. So point I'm trying to make is what? When there is a complete reaction, then all the reactant gives equal amount of product, and in that case, we don't have to worry about that what is the amount of product formed. But here now, the question arises. Because you see, the reaction is incomplete here. It is incomplete reaction because one of the reactant molecule is still present, right? So if you consider N2 here, so 1 mole gives 2, so 3 moles should give, this should give, 1 mole gives 2, so 3 should give 6 moles of NH3. If you consider hydrogen, so 3 moles gives 2, so 6 moles gives 4 moles of NH3. So which one is correct? This one is correct or this one is correct? That is the question. Are you getting it? Are you getting it? Till now it's fine. What we are trying to understand, right? So in this case, when the given number of moles is not in the ratio of their respective stoichiometric coefficient, in that case we'll apply the concept of limiting reagent. Okay, so concept of limiting reagent will be applied in balanced chemical reaction, plus the initial number of moles will be given in this. Initial moles will be given always. Then only we can compare, right? So when we have balanced chemical reaction, the given number of moles is not in the ratio of the stoichiometric coefficient, then we apply the concept of limiting reagent. Now, what is limiting reagent? Write down. Limiting reagent is the reactant. Limiting reagent is the reactant which gets consumed completely, in the reaction, to give minimum amount of product. So you see the previous reaction I have taken, N2 gas plus 3H2 gas gives 2NH3. So reaction must be balanced for this. To apply this concept, reaction must be balanced. Write down the limiting reagent. It is a reactant which gets consumed completely, to give minimum amount of product. Okay. So the condition was this. The condition in the previous case was this. We have taken 3 moles of this and 6 moles of this. Right. So see, when the reaction starts, what happens? The first mole of this combines with 3 moles of this, forms 2 moles of NH3. The second mole of this combines with 6 moles of H2, gives 4 moles of NH3. But at this case, there is no hydrogen present into this. See what happens after some time. 1 mole combines with 3, right? Or you can say like this. 3 moles of H2 combines with 1 mole of N2. So 6 moles combines with how many moles of N2? Tell me. 3 moles of hydrogen combines with 1 mole of N2. So 6 moles of hydrogen combines with 2 moles of N2. So what happens here? I can write down this. 2 moles react out of 3 moles of N2. Here all the 6 moles react. Okay. All the 6 moles react and it gives 4 moles of NH3. Is it right? 4 moles of NH3. So what is the number of moles left here? 0. The number of moles left here? 1 mole. You see, still in the reaction vessel, we have 1 mole of N2 present, but there is no more hydrogen there. So reaction won't proceed because one of the reactant is not available. Reaction won't proceed, and hence the amount of product we formed here is this. So here what happens, the amount of product formed, that depends upon hydrogen or nitrogen. Tell me. Amount of product forms, that depends upon hydrogen or nitrogen. That depends upon hydrogen, because if you add hydrogen into this, further the reaction proceeds. Because nitrogen is available, hydrogen is not available. So hydrogen is getting consumed completely. Hence, the amount of product formed depends upon hydrogen. And hydrogen is the limiting reagent for this reaction. Is it clear? CLR, you can type if you understood this. Right? So limiting reagent is the reactant which gets consumed completely to give the minimum amount of product. Now, once you know this fact that which one is the limiting reagent, after finding out limiting reagent, you don't have to think about the other reactant. Means you don't have to think about nitrogen at all. Once you know the fact that hydrogen is the limiting reagent. We'll discuss Harshini. Wait. Hydrogen is the limiting reagent, correct? Then the amount of product formed will calculate on the basis of limiting reagent only, not on the other reactant one. So since hydrogen is the limiting reagent, so what we can say from this reaction that 3 moles of hydrogen of H2 gives how many moles of NH3? How many moles of NH3? 3 moles of hydrogen gives 2 moles, not, wait, just a second. 3 moles gives 2, 6 moles gives 4. My question is 3 moles gives 2 moles of NH3, right? So 3 moles of hydrogen gives 2 moles of NH3. So 1 mole gives 2 by 3 moles of NH3. How many moles we are taking? We are taking 6 moles of H2. So 6 moles of H2 gives, that is 4 moles of NH3 formed, and hence the answer of the reaction. Is it clear? Right? So for this reaction, what we can say with this stoichiometric coefficient, what information we can have from stoichiometric coefficient? That 1 mole of N2 combines with 3 moles of H2 and gives 2 moles of NH2. This is the information we have from this equation, from this reaction. Now, depending upon these moles, because we can take whatever we want, we can take 1000 moles of N2, we can take 10,000 moles of H2, whatever we want, we can take, right? But whatever amount you are taking, that must react in the ratio of 1:3. Means if 10 moles of N2 consumes, then 30 moles of H2 will get consumed, provided the fact that these two are present in the reaction vessel in sufficient amount, right? 100 moles of N2 react, then 300 moles of H2 react. So the molecules always react in the ratio of their stoichiometric coefficient. Did you understand, all of you? Right? How do we find out limiting reagent? Okay, write down the method to find out limiting reagent. First step is balance the chemical reaction. First step is balancing. Balance the chemical reaction. First step is balance the chemical reaction. Second step is divide the given number of moles with their respective stoichiometric coefficient. Given number of moles with their respective stoichiometric coefficient. Third step, the one which gives the lower value is the limiting reagent. The one which gives the lower value is the limiting reagent. Okay. So you see this example. In this example, you see we have 3 moles and 6 moles we have taken. So what we do, first of all, the reaction is balanced already. In the second step, what we do with this 3 will be divided by its stoichiometric coefficient, which is 1. This 6 divided by this stoichiometric coefficient, 6 by 3. So 6 by 3 gives you 2. 3 by 1 gives you 3. So this value is less. Hence, corresponding to this, the reagent, the reactant, whatever we have, that will be the limiting reagent. Did you get it? Right? Suppose if you take 10 moles of N2, 10 moles of N2 and 45 moles of H2. Which one is the limiting reagent in this case? 10 and 45 I have taken. N2 is the limiting reagent, right? So this is how we'll find out the limiting reagent first, and then once you get the limiting reagent, all calculation will be based upon the limiting reagent of the reaction. If the reaction is complete, then whatever reactant you consider, you'll get the same amount of product. So there is no point of question. There's no question in that, right? When the reaction is not complete, then we'll apply the concept of limiting reagent. Okay. I hope you understood the concept of limiting reagent. We haven't done any question of this. So next class we'll start with the questions on limiting reagent, and then we'll move on to the another topic. Did you understand all the concepts we have discussed today? We also have discussed a lot of questions. Okay, so I hope you must have understood all those things, right? How many of you finished the last class assignment? Okay, it was not more, only 20 odd questions were there. So I hope you must have done it. Okay, if not, then please finish it. Don't pile up the assignments. Okay, you won't get time afterwards. Okay, just keep on doing those assignments. Okay, fine. Another thing, for this class, I have uploaded the assignments on Learnist. Okay, I'll share that, that picture with you. You can log in and solve those questions. All questions based upon moles limiting reagent you can solve. Got it? Okay. Okay, guys, thank you. Thank you so much. We'll see you in the next class. Take care. Bye-bye.